really is hope that Mexico will certainly be able to jump into this battery recycling market. Next, in case you need to get a hold of me, here's my contact information. By all means, do. One last thing, just spoke with my guys in Pakistan, the World Bank guys, and they said Pakistan is very interested in opening discussions with anyone who's interested in their experience, how it's coming along, and to see the differences and exchange information. So anybody that's interested in that, by all means, contact me, and we'll get it. Thank you very much.
Thank you. And now we know we just need to think of patriotism to get out of the box. I'm now happy to pass on to Sandeep.
Okay, I'm going to zoom out a little bit in terms of the entire battery circularity ecosystem and share broader thoughts in terms of how different countries are looking at battery circularity, with especially Taiwan, India. If we go on the next slide, I'll also keep this short because it would far more time. In India, in particular, battery demand is expected to exceed 1,000 gigawatt-hour by 2050. After 2030, it is mainly going to be because of increase in electric trucks and buses, which are going to have very large amount of batteries. If we go on the next slide, what this is going to be, this battery circularity is eventually going to be more and more critical from the perspective of energy security, material self-reliance. It is expected that battery recycling itself can meet 40% of India's total demand by 2050. Supply chain resilience, broad job and market creation, as well as export readiness. So all of the broad economic goals that the country has. And all in all, circularity can also unlock almost 35,000 crore rupees. I can't calculate that into peso per year, dollars on the fly right now. But between recycling opportunity as well as economic activity, save emissions, as well as say land use and water use, it's going to create a massive opportunity in terms of economic activity as well. If we go on the next slide, this is kind of the slide that I kind of want to focus on with respect to this discussion. It's kind of a good thematic in terms of what exactly battery circularity means. It's not just recycling. The step one is always looking at battery production and tackling it there in terms of how you make sure that the longevity of battery and performance of batteries is going to be strong. And after that, the circularity has 4R framework. One is reuse. The first R is reuse. So basically, can you kind of repair and reuse the same battery for electric vehicles or different kinds of electric vehicles? The second part is repurpose. So if a battery is no longer usable for electric vehicles, can you use it and repurpose it for stationary storage or any other applications? Third part, if that also doesn't work, is then recycle. So can you recycle the batteries and how much content can you get out of it? And then the final part is recovery. So recovering the battery, if none of these options work, then recovering the critical minutes from the battery. And that kind of creates a holistic framework between reuse, repurpose, recycle, and recovery. If we go on the next slide, I have just a few slides, but I'll kind of instead of going into details. There are a few supporting conditions that need to exist in the market to support circularity. One is policy, second is traceability, and third is finance. So those are my three sides. Particularly on the policy, as I said, like everything needs to happen all the way from cell manufacturing to OEMs working on circularity, battery waste management system, reuse, repurpose. In India, there is already battery waste management tool, as part of which the OEMs and battery manufacturers, producers have extended production responsibility in terms of making sure that they're taking care of the recycling as well as recovery of batteries. And there are suggestions in terms of improving manufacturing itself and broadly incorporating circularity in different parts of the supply chain. If we go on the next slide, traceability is the second foundation that needs to be there in the system in order to have circularity. What this means is making sure that the recycling of the batteries or the components of batteries are being tracked and traced. Currently, India has this concept of battery passport, which is called battery Aadhaar in India. Aadhaar is like the social security or identification number. So battery Aadhaar concept has been in conversation since last year. Ministry of Road Transport Highway came up with the first draft of how that could look like. And the whole idea is that batteries' static and dynamic characteristics will be monitored through a unique battery Aadhaar number. So that would include everything right from how the battery was manufactured, different components of the battery, different characteristics, as well as the state of health and performance related aspects. So the whole idea is the better you can trace, the better you can make sure that the entire circularity system is ahead. And then the last slide is on financing. We started the day with conversation on financing, but when it comes to circularity, financing is going to be a critical element, and especially at the refining cell production side, large scale equity, viability gap funding, public-private partnership, and concession finance is going to be required, so that more and more investment is going to be unlocked in terms of just feeding into this entire ecosystem. So that's kind of a high level overview on my end. I will pause there and pause there.
Hey, good afternoon. I'm Frank Harley, the Chief Strategy Officer of GRSD. We are a Hong Kong-based company with manufacturing facilities in China. And what we do is we make a better glue or binder, which holds all the active materials onto the electrode. It looks like that, like a glue, but it's very high tech. And it's critical for the battery performance, for its energy density, how long it lasts, the electrical conductivity. Now, there are problems with conventional binder, what everybody uses. Two big problems. Number one is it's a PFAS forever chemical. Who knows what forever chemicals are? Put up your hand. Yeah, so it's a big problem. It's in your clothing, your waterproof clothing, your kitchenware. It's a toxic chemical that's been spreading throughout the world like a toxic microplastic. It's in all our bloodstreams now. And not many people know, but binder in the battery is a source of forever chemical. So as we scale up batteries, we don't want to scale up the forever chemical problem. So we developed a battery that has no forever chemical. And number two is the conventional binder is difficult to handle during recycling. Now we had a lot of magic earlier or throughout the past 2 days. I also have a magic trick which I would like to show you. I need to because I don't know where our magician went. But he's the problem.
Should I fix it? You can.
So this is the cathode of an LFP battery, which you would find in most of the two-wheeler, three-wheelers. You can see underneath this is some aluminum collector foil, and our glue is holding the active materials on the electrode. Now to start the magic. Normally, to remove the glue, you would need thermal treatment or heavy acids. Not acid. But for us, all we need to do is a little water. If you can shake it, please.
Do I have to drink this?
No, I drink that. Cocktails are dangerous. So you can see, I think you can see from the audience, the black part, which is the black mass, is separated from the collector foil. Next slide. So I just showed what happens here. So the key points from the recycling perspective are you can get a very high purity black mass very easily with minimal investment locally. So this is valuable for all your fleets of two-wheelers, three-wheelers, you could set up almost backyard recycling to get black mass and then sell that to international battery markets. I have a video to show how that translates into an actual battery. Next slide, please.
The alternative is very energy intensive shredding.
Shredding, and then to separate the glue out, you need heat treatment and heavy acid, harsh acid. Make it play. Yeah, so this is a LFP pouch cell that we make in China that's going into the scooters in China. Of course, you would have equipment to open it up like this, but this is just to demonstrate. Simple water, so that sandwich of electrodes, the black mass separates. We can filtrate the water out, filtrate out the glue, and then you have a black mass, which you can then sell to people who process black mass for a new battery. You have your local aluminum, copper. Next slide, please. So how does this translate into on-the-ground benefits for communities? We are doing a project now in Bangladesh. They have 6 million trikes there that look like this, rickshaws, that are lead acid powered. They've been doing this for a decade. So the infrastructure is there, the charging behavior is there. It's all working, but using very inefficient, toxic lead batteries. And you can see the way they recycle there's big lead poisoning issues in Bangladesh. So we're getting funding now to replace it with our non-toxic, non-PFAS. We're not replacing one toxicity with another toxicity. Batteries, which can be recycled locally to a high quality black mass. So this brings down the cost upfront because we know in 3 to 4 years we'll be able to recycle and get this black mass. And in a market like Bangladesh, if we've converted all of these to our type of battery, that's 6 million. That means every 3 to 4 years, so about 1 million batteries will be coming up for recycling every year. That's almost 6 gigawatt hours of battery that we can extract black mass from that. So it's going to be valuable in the future. A couple key points. We've made this innovation. It's a small innovation, but has a big impact for circularity. There's no change in the battery chemistry, no change in performance, no change in cost. So what we need is fleets like yourselves to tell your battery manufacturer supplier, I would like to have a material like this in my battery so I can have this circularity. We are already working with 8 OEMs in China, providing our binder, so we know how to integrate with them. And then we'll help you have this circularity story. Probably will help also raise funding for this kind of conversion programs. So these small changes, we'd love to work with all of you to try and help improve circularity. Thank you.
Thank you, Frank. Definitely, I think a contender for the award of most interesting presentation.
Thank you for my
assistant, of course. So the first question I'd love to ask all of you is, in a lot of the global south, the electric 2 and 3 wheelers that are operating are quite informal. So it may be the case, for example, in Bangladesh, like you're saying, you may buy your 3-wheeler and you own the batteries and you drive off. Or in Uganda, for example, you buy your electric motorcycle with a lithium-ion battery, and if you buy it with the battery, you drive off, and when that battery is dead, how do you get it again? So my question for you is, how do you see us intervening to make sure that those batteries at the end of life don't end up in a landfill, but can go back for either repurposing or recycling? Maybe Horizon can start with you.
So this is a big question we had in Malaysia early on, 15 years ago. One of the things we insisted on is every vehicle, every EV or EV battery imported to the country or produced domestically must have identification on it telling what is the chemistry, voltage, current, blah, blah, blah. And that's pretty much universal now. I believe that's part of all standards. There was fear originally that there would be battery dumping. And it turns out everyone recognizes there are valuable components in the batteries. Instead of seeing battery dumping, what we usually see is people drive the electric vehicle, maybe they change the batteries once or twice, and at some point, the vehicle is so old they don't want it, they dump the vehicle. And so fairly often you'll see, and where do they dump the vehicle? They dump it at a motorcycle scooter repair shop. So if you want to see what happens, you go to a motorbike repair shop and you'll see all their dead electric vehicles. And you say, hey, where are the batteries? And oh yeah, the scrap guy picked them up on it. So it was anticipated to be a very big problem. In Malaysia, at least, we have not seen it being a very big problem because there's no value to these things. The only thing I really want to caution people on is the batteries that contain cobalt. Those are the ones that tend to be more flammable and need to be handled more carefully. And of course, there's standard battery handling things to make sure they're discharged, etc. So that's been our experience.
I would second that, and I also think the traceability aspect is going to play the biggest role. There are a few countries like US and Europe where the battery passport concept has been implemented very well. But there needs to be more and more conversation in terms of how can you track health, how can you track the location, as well as all of the chemistry related aspects with respect to batteries. So stronger quality push in terms of traceability as well as EPR guidelines that create more onus of responsibilities on the battery manufacturers or OEMs themselves in terms of taking that responsibility is going to help. I don't know how scrappage would play a role in here too. There's a lot of conversation in terms of old IC scrappage incentives that can support with EV kind of buying EVs in multiple countries. That's one of the policy incentives, but some version of that applied for EVs, especially on the battery and flow.
And I think make recycling as profitable as possible. We've got batteries performing really well for most general needs. Prices have come down a lot. I think the time is now to focus on designing for sustainability. We're an example, but there's other areas in the battery that could make it easier to recycle how the pack is designed, and so that people really want to take the batteries back. NMC is fairly profitable. LFP, the most common for all of our vehicles, is hard to make money on. I think with our technology, we can make it marginally profitable, but this is some big economics.
Thanks. You started to touch on what my next question is going to be, which is around traceability and battery passports. So maybe for the audience, it would be really helpful, Samita, if you could tell us a little bit more about what the experience has been in India and how exactly having battery passports helps with circularity at the end of the day.
So battery passport in India is relatively nascent. So it's still in the concept stage. It hasn't fully been deployed. So as I mentioned before, last year in 2025, Ministry of Road Transport Highway came up with the idea of battery Aadhaar. As I said, like battery Aadhaar is basically like unique identification number that's used for like personal identity, but there are kind of same concept in terms of battery as well. So the whole idea is the better you can track the battery from the perspective of how it is performing, from the perspective of how the chemistry of the battery is, state of health. It's going to be better and better to kind of trace and track its performance and eventually support with the circularity process. But again, multiple stakeholders need to kind of come together in terms of making sure that the battery, Aadhaar or battery passport kind of concept is really going to work out. So it starts all the way at the cell manufacturer level where they are going to be responsible and cell and battery pack manufacturer level where they are going to be responsible at providing that battery identification number in the first place itself, followed by that OEMs who are then eventually going to take that process forward from there and really start tracking different kind of data. Eventually, when it goes to fleet operators or your consumers of electric vehicles, customers of electric vehicles, who then work on making sure that the batteries are well managed and all of the data is being able to track, and then it finally goes back to the recyclers or different recovery companies who then can essentially who then can trace and track the entire ecosystem to be able to most effectively provide the solution. So I think multiple stakeholders really need to come together. If there is battery swapping system, then it adds additional layer of complexity in this ecosystem. So currently where the India conversation lies is the initial draft is prepared. There are set of characteristics that have been proposed in terms of what all things could be tracked as part of this concept. But ultimately it's going to rely, implementation is going to rely on how well different stakeholders have on.
Does the battery tracking, does it extend to the pack all the way down to the cells?
All the way down.
Thanks, President. Frank, I wanted to first ask you as well what you thought of, the idea of having these battery methods, how helpful that is with your innovation in particular in mind. And as well, after that, what is your ask for policymakers to help ensure, that your and other innovations that improve the environmental impact of these cells is picked up?
Thanks. Actually, we have been lobbying the EU's been pioneering the battery passport as well to go beyond just carbon footprint and the origins of materials. For example, the big one is, are you including the PFAS in the battery? Because it's the main one is in the binder, but there's also in the electrolyte and other parts of the casing. I think that will come eventually. And then also, better quantifying the recyclability the battery, how much of it's been designed for recycling. So this would be our ask is to extend actually the battery passport, and it takes time, but we are working.
Thanks, Frank. So Horizon in Malaysia, they're very ambitiously setting up these battery recycling plants, which is fantastic to see. Are there plans to then process the black mass and turn that into raw materials that can then be used in cell manufacturing, or what's the next step? What is that?
Yeah, they're extremely aggressive, and currently the black mass is exported to countries which are currently making battery. However, Malaysia also takes a somewhat different approach. We have Chinese battery pack manufacturers in Malaysia building packs. Currently, they're only for hand power tools. They say that as the EV sales go up, that they will move into EV battery pack manufacturing in country. As soon as there's demand for it, I'm sure the black mass will be used in country. Currently, it is sold back overseas to battery manufacturing companies, predominantly back to China, because there's a large exchange between China.
Just to be clear, there's currently a bigger market for power hand tools than there is for EVs in Malaysia.
Currently, there's in-country manufacture of the battery packs for the power tools. And there's a huge demand for that, but they're also exporting these globally. We don't have, because of manual labor costs in Malaysia, it doesn't make sense for us currently to be putting together our own packs until the scales go up. It undoubtedly will happen, but currently there's just not a lot of second-hand EV batteries. Partially because Malaysia was blessed with cheap petroleum, which means it's cursed with inefficient infrastructure and combustion vehicles. And it's going to be many years before we have enough batteries to really justify the plant that we already have.
Well, but thanks, Horizon. I'd love to open it up. I saw a hand in the back there from Benji.
Two-part question to the whole panel, and this is from a newbie, so I don't know very much about battery type. Two things I do know is that the technology is still developing very fast. So as you talk about building the circular economy, and we get new chemistries, like sodium ion is now a new thing. CATL just released their solid state battery, and we know that's going to get better and better. How will that affect the plans for circularity and recycling? Is it all just black mass? Second question, is a circular manufacturing system and recycling, does battery as a service meet that need or merge with it better so that there's no, oh, I have to dispose of it and I have to figure out where to dispose of it, right? Like, because we have disposal rules where you dump old oil. And of course, it's never followed. But if you have battery as a service, it meets both the new technology, refresh whatever the chemistry is, and also that it stays within the kind of the path of the battery.
I can briefly touch on those two. The first one, Battery chemistries are changing so quickly. Like in the example of Bhutan, where we were projecting in 2050 they would have enough volume of battery. The technology in 2050 is going to be totally different. Forget about it. Don't even plan that far ahead for the chemistry of the batteries you're going to recycle. So absolutely, you're very much correct. If it's going to take you 5 years to get ready, by the time you're ready, the technology must change. The second part, at least in Malaysia, battery swapping, yes, it greatly improves the circularity. For example, Oika is one of the producers of vehicles in Malaysia, the Blue Shark. They do the battery. They recycle and reuse their own battery. They rework them for quite a while, and then once they're beyond a certain state, they go down to the cell level because they're the actual cell and manufacturer.
Yeah, just kind of wanted to plus one on that. I think in terms of battery chemistry, yes, it's going to keep on improving. The whole idea is to make sure that the battery density, initial density of batteries keeps on improving. But there are going to be some factors which would still remain constant in terms of what kind of could potentially still remain constant is with respect to the recovery methods, a lot of critical composition will be similar. So I feel like the existing systems could still potentially be relevant in the future or can be retrofitted to kind of incorporate and accommodate new innovative battery technology. So I feel like because the battery chemistry is going to change, not starting with battery, looking at battery circularity definitely is not going to be the solution. So we have to incorporate it right from the beginning. And battery swapping also is a really good way to introduce traceability into the entire ecosystem with battery as a service financing models or infrastructure models. Traceability is already incorporated into the whole ecosystem, and it also supports the standardization of batteries eventually. So I think those elements support the broader circularity conversation.
Yeah, in theory, battery swapping should be hugely beneficial for recycling. Sometimes I see a bit of a disconnect because I talk to the swapping company and they don't get a really clear vision of what they were planning to do actually on the recycling side. Because for me, I think, oh, my technology will help you recycle that. I assume you're going to at least get to the black mass internally. So I want to learn more about what all the swappers are planning for their own recycling. And yeah, this on the chemistry side, yeah, for us, the sodium ion is the big one coming up. Our binder works well for that, actually improves the performance of it. But we're also evaluating because the value of the sodium is so low for recycling. We're trying to figure out how does it make sense on recycling. So
one caveat I wanted to add on battery swapping though, it adds traceability from circularity perspective, but at the same time, it means that you almost have 1.5 on average times the number of original amount of batteries that you have gone with the charging. So yes, you are going to have benefits in terms of a reduced downtime, in terms of like creating more widespread network and less kind of time with respect to charging or swapping the vehicle. And circularity, but you're also talking about way more batteries in that ecosystem eventually.
An interesting concept which we see with battery swapping, usually you don't consider is usually the battery swap batteries are returned with a lot more charge than that, meaning they're not discharged as hard. If you own your own vehicle battery, you tend to charge down like your handphone, you charge down and up. Battery swap, because they can go swap the battery at a time, they're typically returned with around 40% of the capacity remaining. They've only used 60% of the capacity, which means instead of having a normal lifespan of 1,000 to 2,000 cycles, we're talking maybe 5,000 cycles. So even though you have to have twice as many batteries, they last much longer than normally anticipated from
if I can also add a caveat. I think that's very interesting. I think that one of the key things I've seen is that battery swapping behavior depends on so many factors. One of them being what local incomes are. The other one is what the use of the vehicle is. The other one is how easy it is to find a swap station. And then a really important one is how you pay for the swap. So in some cases, for example, in richer countries like Taiwan, you have the systems like Gogoro where you pay a monthly subscription and then you pay that and you have a limited number, but quite a few amounts of swaps. So you're not thinking about paying when you're doing the swap, right? Because you make one payment a month. That will never work in most of Africa. I don't know if it'll work in anywhere that's sort of low income. What instead is needed, especially by commercial users, is you pay for the amount of energy that you use. So that means you show up at the station, you have 25% of the battery left, so you pay 75% because you use 75% of that battery. You pay 75% of the full price, and that changes how you think about it, right? If you pay the same amount every time you swap, then you would maximize how much energy you're using. You'd be more likely to bring that battery all the way down. You'd be more likely to damage the battery, right? So there's a lot of factors that go into this sort of thing.
I know I'm indulging on this topic right now, but I think with battery swapping, in addition to how you're making the battery, it also depends on what vehicle the battery is being used for, because it increases swapping sometimes increases productivity. If you look at trucks, if you have a swappable battery, you are able to have smaller size of battery, which means your truck is going to be able to have larger load and eventually fewer trips. So many things are to be considered when it comes to circularity and swapping.
Absolutely. Any other questions?
It's maybe going deeper into Benji's first question. Can maybe two parts. Can you speculate a little bit more on the newer battery? Like, does it make sense to keep on thinking about sodium solid state? And then sort of the related question of is it good to have many different types of battery like circulating? Is there a way to sort of commit to one? And just, maybe it's a huge stupid question, but I sort of trying to think what is the best way forward in the places where we're just starting to see many more vehicles with battery. Yeah, maybe there's more.
I think the diversity of batteries is all right. I mean, chemistries, because they all fulfill different needs. Some LFP is good for some, NMC is good for one. Some solid state will be more expensive, but good for some uses. Sodium is good for some. So it's just figuring out which ones are the best uses. So there will always be a diversity of chemistry. I don't think we need to have one standard.
It's probably inevitable that in the birth of new technology, you have many different kinds of implementation. Internal combustion engine, you have so many different configurations. Eventually, they standardize 4-stroke, it's very likely that will happen with batteries as well. We'll undoubtedly have some different chemistries for extremely purposes, but for vehicles, it's probably likely that within 5-10 years, they'll standardize on one battery until it's replaced by a significantly better technology. One thing that a lot of governments try to do is they mandate. We want only this battery, or let's eliminate that battery. And government controls to the market don't generally work extremely well. Sometimes they can provide subsidies or incentives, and those can help shift the market in a more in a smooth manner. And I would tend to prefer those sort of gentle pushings of the market as opposed to absolute bans. Because in the end, a government should treat a technology as a black box. What happens on the inside? Don't know, don't care. I care what are the inputs and the outputs, and is it safe, et cetera. So I always try to push for performance-based governance, specifications, et cetera. Let the technology be a black box, let the market decide.
Thank you, Rising. And we're gonna have to wrap up here, unfortunately, but you can approach all our panelists afterward, particularly if you want to ask Rising why he is supporting Shell. Yeah. Yeah, please, a round of applause for our panel.
Gracias por llevarnos a pasar las baterías. Vamos a hacer una foto grupal. Ayer hicimos foto grupal, hoy vamos a hacer foto grupal, vamos a hacer cafecito y luego vamos a volver a lo más sencillo, más importante. Escuchar operadores y operadoras. Así que un aplauso para la comunidad. Somos visuales. Vamos a ir a casa. Cualquier persona que se considere fuerte, ayúdanos a abrir esa mano. No hay que salir, solo hay que salir. Solo hay que salir, ¿verdad? Ahí está eso, Diana. Yo creo que sí puede salir, ¿no? Creo que no hace falta abrirlas todas. Con salir ya es suficiente. Bueno, sígueme. Vamos por acá, que hay que hacer esta foto. Y hay que tomar cafecito. Gracias a la gente que está aquí apoyando.